Great to see you here again. This is a new video offered to you by the Custer Academy. We're still talking about samples. We are still talking about samples, the sampling error, and the central limit theorem. And in this video, I will look deeper into proportions and the sampling error related to proportions. Now, but before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Now let's have a look at the proportion sampling error. We're looking at proportions now. Now we looked at the previous examples. We looked at the sampling error based on the population, and we tried to find the sample mean, or we calculated the sample mean. Now when we have a population where we have yes or no, or good or false, now this is a little bit different. Here we have only two possible answers. We have yes or no, heads or tails. We can look at the people and say how many of them went overdraft on their account that month. So it would be a yes and a no for people who didn't go overdraft on their account. Now here we look at the proportion, and we have either yes or no, so we can calculate what is the proportion of yeses and nos in that population. Now the population size in this case, we look at n, capital N, equal to 500. And in the population, when we looked at the answers, we found 455 people who answered no and 45 that answered yes. So now what we can see is to go to the next step and do a sample with n is equal to 50 people. We're looking at the same population, but instead of measuring all of them, we just select 50 as a sample size. And when we look at this, when we look at the population proportion, I call it pi, is the fraction of values x in a population, capital N, having a specific attribute, in our example, no. So the population proportion here is x divided by n. In this case is 455 divided by 500, which is 0.91, or 91% of the people did not have an overdraft on their account, and they answered no. The sample proportion is the same thing, but now we are looking at the fraction of items in a sample, and we have small n, and we're looking in that sample how many people have the attribute of interest, in our case, no. So when we look at p is x divided by n, and we have two possibilities. We have the minimum value of p, so we find 5 out of 50 who have in fact answered no, so that's the worst case scenario, and p max when we select 50, where we select only people who answered no. So when we look at it, we can find 5 people out of those 50 that we found which have answered no, or all of them. So it depends how we are looking at these elements. So we see that the sample proportion can be between 0.1 and 1, where the population proportion is equal to 91%. Now when we look at the sampling error, and we look at the single proportion sampling error, which is the difference between the sample proportion and the population proportion. The sampling error in this case is p minus pi. And when we calculate the sample error, we'll calculate it for the two extreme situations. Situation 1, we selected 5 out of 50, which were in fact no, because we have maximum 45. So we can select 45 yeses or no's out of 50, but we still have 5 that can be no. So basically we find 0.1 minus 0.91 is a sampling error minus 0.81. And for situation 2, we have 1 minus 0.91, we have 0.09. So this is the same principle as the sampling error when we were looking at the population. Here we look at the proportions sampling error. Now, let's have another example. We have a customer satisfaction survey over 100 customers. We have happy customers. Yes, it's 92. unhappy customers now is 8. We find that the proportion here of happy customers is 92 over 100, or 0.92, or 92%. Now we do a sample and we look at the possibilities now, what is going to happen. Now we select 20 out of those 100. And in the worst case, I select 8 of them who are unhappy customers, and then the 12 remaining are happy customers. So basically what we have here, the minimum sampling proportion is 12 over 20 is equal to 0.6, and Pmax is 20 over 20, which is equal to 1. So basically we find here the sample errors. For the first case, 0.6 minus 0.92 is a sample error of minus 0.32. And for situation 2, we have 1 minus 0.92, which is equal to 0.08. Now when we look at the summary of those and we look at the sample distribution with different sample size, we can find those values, we can do those samples, and we find a very nice overview when we have the sample distribution between 100 to 500 samples. Now we can also look at the sample size n is equal to 10, and out of 100 samples we look at n equal 10. So we have 100 samples that we did, we find an average of 113. 200 samples we find 114. When we have more samples, we find 114.181, 114.178 when we have 400 samples, and when we have 500 samples, we find 114.189. And we see that the average is moving towards 114. So we're going closer to an average of the population, which is 114. Now, when we look at 500 samples here, we have a mean of 114 and a standard deviation of 4.3. Now we have a sample size 20. We find 114 and a standard deviation which is comparable. When we look at the combination of the sample sizes 10 and 20, we see those different distributions, and we see that there is an evolution. The orange distribution is going closer to the population. Now, when we look at the sample distributions, when we have, let's say, the conclusions here, all the samples have been taken from the same population and represent a small fraction of all possible samples. Taking more samples with the same sample size seems to reduce the sampling error and to reduce the standard deviation. When we take more samples, the sampling distribution starts to look like the normal distribution. And when you look at the graphs that you've seen before, you will notice that this is in fact true. The more samples we take, the distribution of the sample averages will look closer to the normal distribution. So basically that was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and bye-bye.